What's up, Terry? Who'd you bring today?
We have a friend. Are you happy?
I'm happy. Well, I'm not friends yet. Is that
Yeah,
too judgmental?
we're working on it. We're working on that. We're working on that.
Any
Yes, we
friend of Terry's is a friend of mine until proven otherwise.
we have the brilliant Larry Great, and I do not use that term lightly or loosely. He will tell us a little bit about himself, but Larry is let's say an OG industrial automation and control specialist, comprehensive. So I think a lot of our overlaps in the industrial space will find this discussion very interesting.
Can I shortcut the introduction? Is that
Go,
fair?
go right ahead.
Larry, I have one question for
Yeah.
you, and then there's a bunch of sub questions to it probably. But I think this is going to take the whole time. Based on that intro that Terry just gave, I want to know how you feel about the next, I don't know, 10 or 15 years of industrial cybersecurity and systems. And the sub question is, should I point my ship that direction and go like become a cybersecurity for OT guy?
Oh, wow. Okay.
Yeah,
So
this is an easy softball right off the bat. Just solve my entire life for me, please.
that might be a challenge to say the least. So where do I see operational technology going in the
Like, are you
next?
bullish or bearish on specifically cybersecurity for OT?
Oh, I'm bullish on cybersecurity for OT. I mean, if I look at what's going on in the world around us today, even with kind of some of the current things happening in Pennsylvania and Texas around the Unitronics attacks from what is probably Iran. I mean, obviously, I don't want to probably attribute things, but likely that's the culprit. That I think that's just the tip of the iceberg of what we're going to see over the next several years. I mean, you've seen ransomware tick up in the space at incredible rates over the last probably 5 years. Kind of going into COVID, and so I think you're going to see more and more companies becoming aware of what the risks really are and trying to do something to mitigate those risks to the best of their ability. So that's what I see happening in the next 5 to 10 years.
And we were talking about the Unitronics attacks. This is a PLC based attack, is that right?
Yeah, I mean, Unitronics is PLC slash SCADA, right? So it's a little more than just a traditional PLC and tends to be pretty entry level, which is why a lot of water wastewater facilities end up using it.
And what's your? This may be an impossible question to answer, but how would you describe a PLC if you had to do it at a dinner party?
How would I describe a PLC if I had to do it at a dinner party? Wow. So I can't use technical terms.
Well, hold on. What's being served for dinner? Give him some context.
There's like a pot roast, and it's already been served, and it's like cut, and you can see the piece that you want, and the line is starting to get long, but somebody's got you cornered, and they're like, you cannot get through to the line until you can explain what a PLC is.
So I like to describe operational technology as IT with physics. And so the way I would describe a PLC is I would say it's an embedded computer with a very specialized purpose of interacting with the physical world.
That seems pretty legit. Terry, do you give that a or above?
I don't know.
Probably a solid B, right?
I think we need to hear how said embedded computer is used. But yeah, that is, if you're trying to make your way to a cut of roast beef quickly, that was a fantastic answer.
The problem is it's used for everything.
A lot of everything, right? So it's used, and especially today, because you've extended the functionality from what it was originally created for, i.e. sequence of events, the automotive industry, kind of where it got its grassroots start, into being used in every industry you can imagine today, as you've really evolved from a PLC to what some people call a PAC, or a process automation controller, where now I can do, temperature, flow, pressure, so on and so forth. You got Rockwell extended the functionality of their Logix family and kind of calling it a DCS. And with very few exceptions, they've closed a lot of those gaps, right? So today PLCs are used, in a number of different applications across things and places you often wouldn't expect. I mean, former employer actually was looking at using them for automating even the delivery of fast food in a hamburger joint or something like that. Essentially, actually, literally cooking and providing final content ready for somebody to pick up and hand to somebody out a drive-through window, and using actually PLCs for some of that automation.
So if you want to be appealing to a completely non-technical person, you can say it's a computer thingy that's inside a lot of robots, and they'll be like, "Oh yeah, okay, it's the thing that's not it's a special robot computer." And if
Yeah,
they
but
can understand anything about the idea of a controller, then you can get into more of it's a series of ons and offs, and then they can get it. You also have to while you're standing in line for your pot roast, you have to judge whether the person you're looking at has any idea what an Arduino is, and then you can just say, think microcontroller but industrial and expensive, and then you also have to run the risk that they're going to look at you and be like, I don't know what that is, and why would you think that I did know what an Arduino is?
yeah, if they have no idea what an Arduino is, it would definitely be a longer conversation, right?
I feel like this is a pretty ridiculous hypothetical for a couple of reasons, but not least of which because they're not like the question is only going to go so far. You know what I mean? Like people don't want to know about the nitty gritty details of industrial controls at all, even though there's a lot of them out there. There's a lot of us out here, but
Yep.
but it's not a dinner table conversation or dinner party conversation.
Not unless you're around a bunch of other controls guys, right? Then it's Katie bar the door.
So how did you find your way there to industrial
How did
controls?
I find my way into controls? Kind of by accident. I actually was majoring in electrical engineering and had a fellow student actually invite me out to a mining operation. And I spent some time talking with the electrical engineer that managed the controls for that mining company. And before I left, he basically offered me a job to come back as a co-op student. And I kind of had a unique entry level into the control field in that the company I went to work for, I literally went from looking at like little single, like GE Series 1 type PLCs, small application, all the way to doing, GE Series 6 with an ASCII module and an Ematron industrial workstation and kind of a predecessor to what eventually would be something like Wonderware, to doing DCS programming all in a period of about 18 months. So I got an opportunity to see a lot of stuff in a really short time period. And I guess I was hooked at that point. And I've been doing it pretty much ever since.
I have so many questions about this. Where was the mine?
Where was the mine? It was actually in a little town called Dublin, Georgia.
Okay. My brother worked at a potash mine for a while in Carlsbad, New Mexico. And he got a job there by way of being willing to work in a mine in Carlsbad, New Mexico.
So this was a kaolin mine in just outside of Dublin, Georgia. It kind of a similar situation, I guess. There wasn't a lot of people willing to get that dirty, essentially. I mean, kaolin's not quite like potash from a safety perspective, I guess. It's an inert materials, but it gets in everything.
All right. So what's the stuff being mined? Is it dirt? Is it rocks? Is it something like, I don't know this at all.
Yeah. So kaolin clay is a white mineral, white powder. It's used as a extender for titanium dioxide and paint. It's used to actually paint the white lines on basketball or baseball fields. It's used in lots of other places, essentially. In fact, most shiny paper actually has a very thin layer of what's called calcined clay on top of it. Actually, it's part of what gives it the shine, essentially, on a magazine cover or something like that.
And how's this stuff coming out of the ground? So I'm trying to get to, you're talking about seeing the controls and you like the controls and you fell in love with that. But I want to know, what was being controlled. Are we talking about a cart? Are we talking about, drilling equipment?
Okay.
Are we talking about like a conveyor? Describe the, Mr. Rogers goes to a mine version of this.
Yeah, so the small NPLCs were doing sequence controls on like conveyors. So it comes out of the ground kind of like dirt. You dump it on a conveyor belt. You run it over into what's called a plunger, and you mix water and chemicals in with it and turn it into a slurry. And from there, it gets pumped into the plant. And then from really its arrival in the manufacturing process until shipping, it's all about improving or either getting the particle size to be consistent, getting the brightness or the whiteness, increasing the brightness or increasing the whiteness, and as a last step, a lot of times what's called calcining it. So actually driving water molecules out of the actual mineral itself and then drying it, right? So we would ship products, everything from kind of a noodle. So imagine an oversized plate of spaghetti where the spaghetti noodles are maybe close to a 1/4 inch in diameter instead of being really small, to shipping dry powder that looks very much like confectionery sugar, for example, and everything in between.
I'm assuming that you were interested in how stuff gets made from a young age based on your electrical engineering and your interest in the mining process and the amount of recall you've got for exactly what it looked like.
So I spent a lot of time in that industry, probably 5 or 6 years, which is probably where some of the recall comes from. And then had a chance to continue to go back and work in them after I started working as a system integrator full time. If you go back into my childhood, yeah, I mean, I was always really curious about how things worked. I mean, to the point where as a 13-year-old, my parents had this 1973 Ford station wagon with a 429 big block engine in it, and I desperately wanted to drive that car when I turned 16. My dad was threatening to sell it, so he takes off to go play golf on a Saturday morning. They were having trouble with it at the time, and he comes back, and I got the whole front of the engine torn off and the timing chain out, and I'm like, "Hey, let's go get a new timing chain and get this thing back up and running." So, yeah, I guess you could say, in fact, it's kind of interesting you say that. I used to work for a large system integrator, and one of the questions we would often ask co-ops was, did you ever take your toaster apart? And it wasn't so much because we were curious, had they actually taken their toaster apart? It was more because we wanted to see would they come back and respond with, well, no, I've never taken a toaster apart, but I have, right? Whatever it is that piqued their interest, that caused them to want to dig into kind of how stuff works.
Right.
That whole TV series to me was a lot of fun. I really enjoyed that.
I still enjoy it.
Yeah, absolutely. I'm with you.
Terry, do you take stuff apart?
No, Terry doesn't take stuff apart.
You know him better than I do. I'm learning that there is a gulf between me and Terry, and part of that gulf is whether we take stuff apart.
Yeah.
The other day I was like, Terry, how many disassembled parts do you have within arm's reach right now? And then we had like how many parts do you have in front of you off?
You don't want me to answer that question.
Unlimited. Okay, all right. So today, what are you doing today? I don't care so much about how you got there, but tell me the parts of what you were doing from first interactions with control systems, and give me some continuity between then and what you're doing now.
Yeah, so I went about 20 years primarily developing control systems for every process that I could get as a system integrator to engage me in. So mostly heavy industry, pulp and paper, steel, specialty chemical, that type of thing.
Mm-hmm.
About 10 years ago, became much more interested in what an adversary might do to these systems and how they could actually use them against us. Stuxnet had just become a thing. So I guess it's a little more than 10 years ago now. It's probably closer to 15, but Stuxnet was just becoming a thing. So we had our first malware actually written against these types of environments, and really pivoted into thinking about how do we actually secure these things. And so, what do I do day in and day out today is really help our customer base, including the Department of Defense, think about from a critical infrastructure perspective, how would an adversary use these systems against them? What exists for interfaces that somebody could get a hold of and use to do something malicious with these systems? Help develop architectures, network and otherwise, that are secure. Help put in network security monitoring tools to help understand what becomes normal in these environments, and what an adversary might look like in those environments, that type of thing. Working with a large prime recently on some AI engines actually that are focused specifically at looking at the intelligence that's available out of some of the NSM tools and extending it. So I'm not just looking for the adversary after he's doing something in the environment, but I'm looking for the breadcrumbs that he's leaving as he's coming into the environment and beginning to get a foothold and develop the opportunity to do something even more malicious.
So we're back in line. You've made it past the conversation. You've got your piece of roast beef. You're headed back to your seat.
I know I'm in trouble now.
Yeah. And this person overheard what you just said in another conversation, and they want to know, what are the breadcrumbs that an adversary leaves in an industrial network, and how do you leverage AI to uncover those things preemptively?
Yeah, so the breadcrumbs end up looking so most operational technology attacks have their basis in information technology. And so most of the breadcrumbs that you're going to find are going to be typical IT kinds of things, right? I'm going to see a new network data flow on a firewall that I never saw before. Maybe I'm going to see a new account in a domain controller that didn't exist previously. Or I'm going to see evidence that somebody was in manipulating logs to try to hide the fact that they were doing malicious things in a server. And then after that, I may see a new network flow start up between that server and some operational technology device, a PLC, a DCS system. Could even be in today's world, because we're using Ethernet and routed connectivity all the way down to end devices. You may even see a new data flow to, say, a pressure transmitter or something like that, where an adversary is looking for a way to actually rescale something and cause it to look like you're seeing a reading that actually isn't what the process is currently doing. And so that sequence of events from an AI perspective, you're looking for the initial access before the gaining a foothold in a server, before manipulating logs in a server, before another access path down into the OT environment, and actually chaining those things together using something like, MITRE's ATT&CK for ICS. Does that make sense, Terry?
It does. It does for me, because I have at least, some peripheral understanding of that. I think you might be stuck in that conversation at the dinner party for a while, though.
I'm afraid you're probably right.
Yeah. Well, let's unpack some of this from a sort of a 30,000 foot view, and then maybe work down to the conversation that we had. So I'm going to make a statement, and you tell me if I'm correct and if I'm not.
Okay.
And I know how this is going to go. I'm setting you up here. I don't think the average person in our country, not average manufacturing specialist or controls person, just the average person, understands the risk from critical infrastructure being exploited by state actors. I don't think the average person understands that. Would you say that's a factual in terms of it? So what if somebody gets into the Unitronics PLC in a water treatment plant? What's that mean? What if somebody breaches the DCS of a coal-fired power plant? What's that mean? Or a chemical plant or a manufacturing plant? What does that mean to Bob, who's a sales guy, a medical device sales guy, family of four, never touches industrial controls or manufacturing? What does it mean that our critical infrastructure is under attack, probably daily, hourly, by the minute in some instances? What does that mean for the average person?
Yeah, I mean, to start with, 100% agree with you that I think the average person has no idea of the risks that's there, right? I mean, I think that's absolutely a true statement. And if you want a kind of a visual example of kind of a worst case scenario, we can go back to the Colonial Pipeline incident, right? It was really a ransomware attack against IT, to be fair, right? So nobody ever did anything on the OT side of the house, but because they couldn't be sure that OT was clean, and because they couldn't track from a business perspective what they were doing, they made the decision to shut that pipeline down. What was the impact to the average guy trying to get home at the end of the day? He couldn't buy gasoline, right? I mean, we were on the East Coast of the United States. People were doing crazy things. I mean, I literally watched somebody try to put gasoline in a Kroger bag, right? I mean, I thought, you've got to be kidding. I mean, I watched somebody put probably 20 gallons in a Rubbermaid container in the back of their car. And in the back of my mind, I'm going, man, I hope that thing survives long enough for him to get home and get it out of the car before it starts sweating and leaking, right? Because there's no way it was designed to contain that. But that's the kind of things that happened. It just, that's something we can go back and look at, right? We can go back and actually examine and kind of talk about. On a broader perspective, I think the bigger risk is on the power side of things, right? I mean, I don't think people realize how fragile it's this double-edged sword, right? We can talk about how fragile the electrical distribution system is, and that's a true statement. Yet at the same time, it's been pretty robust for an awful lot of years, where we haven't seen, we had the Northeast blackout. We've had some different things like that happen. Case in point, maybe, you go back to the Ukrainian attacks in 2014, 2015, something like that happening here would have had a much bigger impact, because in Ukraine, they were closer to still physically having somebody they can put in a truck and go out and close a breaker. In the United States, we don't have that today, right? I mean, we really rely heavily on our ability to remotely manage a lot of this distribution equipment. And if you manage to brick that capability, which is essentially what happened in Ukraine, it's a much longer recovery time for us to get somebody to all the distribution stations necessary to start reclosing breakers and make decisions about how we safely distribute power across this country.
I've made this statement here with Russ a bunch of times that we'll see the fragility of modernity in our society if there's a sustained power failure. And I think that's lost on so many people. If the power grid goes down in this country for any extended period of time, that's not a trivial thing.
No, and I think what people don't think about, right? They think about the inconvenience of maybe their personal air conditioner or lights at night or whatever. They don't think about the food supply chain and how many places I need power to be able to refrigerate food, to be able to store it for an extended period of time. Not just what I'm doing in my home, but just the supply chain all the way back to where we're, pulling things out of the ground from a vegetable perspective, or whatever we may be doing with, meat and things of that nature. So, and that's just one example, right? And then you start thinking about all the other things that it would impact, like hospitals and medical care and transportation, because, I don't have power. I can't pump fuel. I can't transport fuel. So all of a sudden, whatever reserves I have in a given location is all there is. And you get to some of these smaller towns and, maybe there's a few thousand gallons in the ground. But once that's pumped out, assuming you've got a generator to be able to do it, you're not going to get any more for a while. So there's a lot of cascading effects of a widespread power outage that I just think people don't think through.
So, question for the group here to level set: have we sufficiently doomstaged? Like, do we have the all of the nightmare scenarios covered that could possibly? Are people properly scared? That's what I want to know.
I hope people don't get scared, right? Because one of the other things that bothers me is the OT cyber community and the whole fear, uncertainty, and doubt, right? I mean, I'd rather not spread FUD. That's not what I'm about. At the same time, I want people to understand that there are very real risks. And those very real risks, I mean, in IT, we talk about securing data. In OT, we talk about securing the ability to do whatever it is we're going to do. But before that, the ability to secure personnel safety, right? And that's got to be the first priority in any OT risk assessment, is understanding the safety implications of what it is that you're doing, and how do you keep people going home at the end of the day.
I have FUD questions.
You have FUD questions? Okay. Well, you can ask FUD questions. I'm not against them. I just hate to see it be the primary thing that drives what we do.
I have no cybersecurity background of any kind, other than I read that. Like, I could describe the Stuxnet attack in Wikipedia page detail, like right now, if I had to. The thing that I get concerned about is, particularly in kind of like industrial companies, I get really nervous about how simple some attacks seem to me. So things like, there was a password written on a sticky note and someone stole that sticky note, or a camera was in the wrong place, or in the right place at the right time for the attacker, and they took a picture of a computer screen. And I think the typical executive that I've run into, particularly not talking directly to me in conversation, but sort of talking from on stage or from the pulpit or whatever, they're talking like they've built this, sophisticated attacker myth. In my opinion, it's a myth. And it kind of makes it seem like security is somebody else's problem because of how sophisticated the attacker is. I mean, aren't there a bunch of attacks that are kind of simple in nature, or human engineering?
Yeah, I mean, if no other reason, right? I mean, you just think about how many wireless access points were used in the startup of a system, and then because nobody really tracked what was going on, it got left installed. So literally, I can drive out in the parking lot, hop on that unencrypted wireless network, and then jump on an unencrypted OT network. And it doesn't take me too long to discover what's there. I mean, if you've got any kind of a control background at all, you can pretty quickly dig through an engineering workstation, for example, and get a good understanding of what's being done at that site and what's critical. And then what do I go after?
And there's not that much complexity to understanding that case. I mean, there are a lot of cases and there's an unlimited number of possible avenues for attack, but things like you get to, the narrative of that example you're giving is there is an unsecured access point available from the parking lot of the building. An executive can understand that. Right? Like this is not a sophisticated attacker breaching the system. The vulnerability is understandable in the pot roast line, and I would like to see more conversation around uh, digestible vulnerabilities and not just sophisticated nation state actor. Although even Stuxnet is pretty understandable as an attack.
It really is. And the more you research it, especially if you've got any kind of a controls background at all, the more you realize how many different ways you leave yourself vulnerable to those kinds of things as you're deploying different systems. I mean, I'll go back to my system integration days, right? You're standing up a new HMI. What's the first thing you do? Well, you turn off user access control, you turn off the firewall, and you assign yourself in as local admin. Well, I've just done everything wrong I can possibly do from a security perspective. And I'm doing that because it makes my job easier. And that's the mentality that I want to see change in the system integration community. There's a lot of really simple things, to your point, that are very understandable that we can do that make even a nation state actor's job much more difficult. We make it easy for them today. Go ahead.
Long passwords. This one blew my mind. So I don't know when this was, but at some point I read, I mean, I was probably pretty young, but it was like, don't worry about more characters. Just make your password a full sentence long, and it can't be brute forced, right? Like you just can't get through that. So I think that's changed a little bit since I read that, but that concept that the complexity comes when you're trying to just basically automatically run each password through a system and test all of the possible permutations. The way to make that impossible is add more characters to the string, not add more options of character. And that kind of hit me like a ton of bricks when I'm like, well, I can just always use a long password that is easier for me to remember. There's no reason not to do that. Like I could use the password, this password is a great password. Fantastic password.
And from a complexity perspective, it may be good. The thing you have to ask yourself is, do you say things like that all the time, right? So as an adversary, if I go look at your Facebook account, am I going to find phrases that you throw out there on a regular basis that you may use some permutation of as your password? That's where the risk comes. But tying it back to OT for a minute, if I could, I'm not necessarily a fan of really long, complex passwords for operators, for example. I'm a fan of using other mitigation controls for an operator station. Don't even put a password on the thing, right? I mean, have it physically locked down, have a CCTV camera pointed at it. Let's use mitigating controls and not make it difficult on an operator to log in when he needs to do something quickly. Completely different story for the system administrator, right? That's a different use case. But I think there's an appropriate way to step back and look at operational technology security from a reasonable perspective. And there are reasonable outcomes that you can come to when you sit around a table and have a conversation about what are the risks, what am I worried about, and what can I do to actually mitigate those risks in an effective way.
What stops that conversation from happening?
I'm sorry?
What stops those conversations from happening?
Well, part of what stops them from happening is the long-term angst that exists between IT and the security community and system integration and OT, right? I mean, we've got a long-standing history of, I don't want these guys in my playground on either side of the fence. And we've got to get past that and actually have conversations with folks. Once upon a time, I made the comment on a Rockwell stage that, I felt like one of my job descriptions was a referee, because I kept finding myself in rooms with 10 or 15 people, and 4 or 5 of them from an operations perspective, 4 or 5 of them from an IT perspective. And instead of talking with each other, they're talking at each other. In some cases, they're using similar words that just had different definitions based on their framework. And so, when so-and-so says this is what they mean, right? I mean, when you say that, what do you mean by that? And that's a lot of just having that open dialogue and saying, okay, what's the real problem we're trying to solve here, and what are the potential solutions to that problem. It's one of the things I'm excited about with what Idaho National Lab's done recently with cyber-informed engineering, right? We're trying to now think about how do we actually engineer vulnerabilities out of a system versus even necessarily worrying about what the vulnerabilities are and how do we mitigate them.
So, kind of a final thought on we talked about the sort of doom scenarios, the potential risks, and then we've sort of moved into what are the ways that happens. Where would you rank phishing on the IT side as the entry point into the OT hack?
Yeah. So again, assuming we're talking about not necessarily just phishing, right? So we're including spear phishing and whaling and all the other variants of phishing, essentially. I think it's the number one way people get in.
So explain these. You've been trapped at the dessert table now. Explain the whaling and phishing and spear phishing. Like what are these mechanisms for breach?
Yeah, so phishing is just basically having a really everybody's gotten these poorly worded emails that come in to say, I don't know, take your pick as to which one they might be, but there's spelling errors, there's things that are just obvious that this wasn't probably somebody that I really need to be communicating with. And they're really hoping that you're going to click a link on that email, that you're going to open a document, that you're going to do something essentially as a result of sending this email out. But it's pretty obvious when you look at the email that nobody really did much thought process about who the destination was, who was going to receive this email. Spear phishing is when you get a little bit more specific and you say, okay, I'm going to send this email to the IT administrator of this company, and I'm going to pretend to be Microsoft, and I'm going to tell you you've got an account problem and you need to click here to resolve your account problem, or your CEO is not going to be able to log into his account at the moment, right? That would be an example of a spear phishing type of attack. And whaling is when you're going after, the CEO, the whomever, and you're using whatever information you can get from an open source intelligence perspective to try to get them to perform whatever action it is you're trying to get them to perform.
Yeah. Would you say that some non-trivial percentage of cybersecurity incidents generally could be mitigated by just not clicking links in emails that you're not 100% sure are yours?
I think it's a lot bigger than some small percentage, right? I mean, I would argue that probably more than half of attacks would be mitigated purely by people not clicking the link or opening the document or whatever it is that they did to essentially start the process.
Yeah.
And then back to your question about OT, just tying it all together, I think Mandiant says 99% of OT attacks started or originated in IT.
Yeah.
And so if I can eliminate those IT attacks, I've eliminated the OT attack, right? That's where they're going to start and pivot.
So this is the nice segue. And I know, we need to have you back. There are a bunch more things that I would like to ask you, but this is a nice segue. So if I am in charge of the security of an OT network, the assets of a critical infrastructure network, there are always exceptions, but what is the number one fail-safe way to protect that network?
Yeah. So unfortunately today, right, the majority of operational technology, even if you go buy something brand new, essentially is not leveraging authentication and encryption to the level that it could be. And so the first thing that you've got to do, in my opinion, to defend any operational technology environment is establish a perimeter. And a lot of people think of that perimeter as being a firewall that would exist between their operational technology and maybe a DMZ or their IT environments. But the reality is there's a lot more to a perimeter than just a firewall. You need firewalls at the network interfaces. But then if I've got somebody, let's go back to Stuxnet, carrying a laptop in from the outside to do maintenance work on that system, well, I just violated your perimeter, right? If I'm allowing somebody to even hand an engineer inside a USB stick with something on it, and it's not being appropriately scanned before you insert it into an engineering workstation on the OT side, again, boom, I've just bypassed your perimeter. The other problem that you have is today, you've got so many OEMs that want access to data, right? We've got all this effort going on in digital transformation and Industry 4.0 and all these wonderful terms, and they're doing some really fantastic things. But all of that increases threat surface and makes things essentially more difficult to maintain because these OEMs want that remote connectivity, and they don't want to necessarily have to work with the IT department. So back to manufacturing and or operations and IT having a conversation, they don't want to have that conversation. So they put in some other kind of mechanism essentially to circumvent getting access to that environment. Usually some kind of cellular modem or other device. There's E1, there's Tofino, there's 1,000. I'm exaggerating, but there's dozens of manufacturers out there that you could use. Ultimately, it's some kind of a cellular channel, and or in some cases, I've even seen people actually go lease a DSL line or some other internet service provider essentially and connect it around the firewall.
Yeah.
So understanding where all those things are. We've done multiple assessments where we end up finding 2 or 3 different remote access solutions deployed in OEM packaged equipment that the asset owner didn't even know was in his environment.
So I want to finish with this, and maybe this is maybe we can just go ahead and plant our flag in a 2-part series here, and the next part is what I would like to segue to. It's the duality or the dichotomy between protecting that infrastructure and realizing all the benefits of digitalization, of machine learning and artificial intelligence, or just plain old having visibility into what's going on. I think that's overlooked as a big tool in the digital tool belt today, is just seeing things that used to be kept on a paper log somewhere. Now you've got insights into that. So it's really the duality between all of the efficiencies that can be extracted from a process, whether it's manufacturing or discrete manufacturing or batch processing, whatever the application is. There are so many benefits from getting the data out of that network, but as you just said, the security concerns with that. So I would like to, the next time we get you back, really get into what are some of the benefits that can be extracted from the data side of it. How can you leverage asset data or OT data in a production environment and make the company more profitable from doing that? So we'll revisit that next time.
Okay, glad to do that. Glad to have that conversation.
Larry, you solved my life for me without even directly answering my original question as to whether this is a space worth pursuing. Your enthusiasm speaks for itself, and one more non-obstacle to me, so I can say one more day, and I'm still not going to give up on digging into industrial cybersecurity systems. So good job, you've done your recruiting goal for the day.
I appreciate that, Russ. It's a pleasure to meet you too.
Thanks so much for being on, and we'll get you back.
All right, sounds great. Looking forward to it.
Thank you, Larry. Good to see you.
Good to see you too, Terry.
Take care.